All right, for this problem, we're going to apply L'Hopital's rule. I low-key love L'Hopital's rule. So what we're going to do is take the derivative. The L'Hopital's rule says that if the limit is indeterminate when you plug it in, then you can take the derivative of both of them, and the limit of the ratio of the quotient of derivatives will be the same as the limit of the original quotient. That's what we're saying. So basically, if I take the derivative, let's call this f of x, and let's call this g of x. I know that this is going to equal the limit as x goes to infinity of f prime of x over g prime of x, the derivative of fx over the derivative of g. That's L'Hopital's rule. All right, so let's do it. What's f prime of x? Well, let's do g prime of, or the derivative of g first is obviously what? It's just 1. And so that one's easy. So we know this is the limit as x goes to infinity of something over 1. So what's the derivative of this? Well, how do I find the derivative of the natural log of e to the 3x plus x?
It would be 1
over e to the 3x plus x times the derivative of the inside, so chain rule. 3 e to the 3x plus 1? Sound right? So that just equals 3 e to the 3x plus 1 over e to the 3x plus x. Okay, so that's still going to be indeterminate. So we can apply L'Hopital's rule again. So now I've got basically the limit of this thing. So let me write that in here. 3e to the 3x plus 1 over e to the 3x plus x.
So what happened to the over 1?
Well, over 1 is just like nothing. Dividing by 1 isn't even necessary in this case, right? So it kind of goes away. And now I can apply L'Hopital's rule a second time, because this also is infinity over infinity. And applying L'Hopital's rule again gives me the limit. So that whole thing equals the limit as x goes to infinity of, let's take the derivative of the top and the bottom. That would be 9e to the 3x. Correct? And what would the bottom one be? 3 e to the 3x plus 1. Again, I'm going to have to do L'Hopital's rule again, because that doesn't exist. Rather, it's infinity over infinity. So let's do it one more time. So that equals the limit as x goes to infinity of, let's take the derivative of the top and the bottom again, 27 e to the 3x and 9 e to the 3x. And now what happens to the e to the 3x's?
Oh, they cancel each other out.
They cancel each other out.
So it's 3.
And the limit of 27 over 9, as x goes to infinity, the limit of 3 is just 3. So your answer is 3.